Hello viewers, in this video we will see the solution to week 3 assignment 3 for the course Principles of Communication Systems 1. Kindly spend time in going through the solutions before or after the assignment submission to get better score, because we may not have enough time at the end of the assignment submissions. For writing exam, you may not have much time later. Thank you. So we'll now see the solution. So first question. First question is about consider the envelope detector with the load resistance RL and capacitance C employed to detect an EM signal with the carrier frequency of C and the message frequency FM. We know that one. It is desirable that for the envelope detector, what is desirable, we will see here. Let's close this one. So RLC, the product RLC is called time constant. It must be, so RLC must be much greater than 1 by FC and it must be much smaller than 1 by FM. That means it is option A. Option A, RLC is less than 1 by FM. Option A, 1 by FM. Second one, synchronization between phase of locally generated carrier and that of incoming signal for double sideband suppressed carrier. It is DSB stands for double sideband suppressed carrier modulation is achieved. Superheterodyne is a receiver. Single sideband, it is the single sideband modulation, no envelope detection. These are all. This is a Costas loop. So Costas loop is the method for synchronizing the locally generated carrier and that of the incoming signal for double sideband suppressed carrier modulation. So Costas loop is a method of FM. Costas loop is a method for DSB-SC demodulation. Coming to third one, consider the message signal M of t sin 40 pi t. Let the carrier frequency of C is equal to 5 kilohertz and the carrier amplitude is AC equal to 10 with 30% modulation. What is the approximate power efficiency of the AM signal? So power efficiency here it is given by eta mu square divided by 2 plus mu square, where mu is nothing but percentage of modulation. So they have given mu modulation index is 30%. So we have to convert that percentage into a number. So which is 30 divided by 100, it becomes 0.3. So substitute this 0.3 in this equation. So 0.3 whole square divided by 2 plus 0.3 whole square, you will get this as 0.09 divided by 2.09. So into 100 you will get 4.31%. So the answer is option B. Option B, 4.31%. Fourth question, consider the signal x of t equal to e power 1 by 4 t ut. Its autocorrelation function defined as, so this is the autocorrelation function they have defined. And what is the integral value now? We have to find out. So we will see the fourth one. So fourth one, this is the integral they have given, autocorrelation function they have given. So I am substituting for x of t, because x of t they are given e power minus 1 by 4 t, and again you minus 1 by 4 t minus tau. Okay. So now what I will do here next is, now here the integration is minus infinity to plus infinity, whereas here this is a equation, general equation. Here I have taken from 0 to infinity. Why? Because u of t in the given u of t here, this u of t is defined for 0 to infinity, between 0 to infinity. That's why the integration is not from infinity to plus infinity, it is from 0 to infinity, and we are not considered u of t. U of t is 1. U of t is equal to 1 in that for that time, for time t greater than 0. Okay, now we will separate this one. So this now I can write it as e power minus 1 by 4 t, and this can be written as e power minus 1 by 4 t dot 1 by 4 tau, because minus minus becomes plus. And then what I can do, because this is integration with respect to t, not with respect to tau, so e power 1 by 4 tau can be taken outside. It is a constant, and therefore now this becomes e power minus 1 by 4, e power minus 1 by 4 minus 1 by 4 t. So this is nothing but 1 by 4 minus 1 by 4 minus 1 by 4 becomes minus 1 by 2, minus 1 by 2. So it is the integration between 0 to infinity e power minus 1 by 2 t with respect to t. Again, this is treated as constant. So if you integrate this one, what you will get is, this is the integration, that is integration of e power minus 1 by 2 t with respect to t is e power minus 1 by 2 t, and the constant comes in the denominator part, which is 1 by 2. So it is between the limit, sub t limit is 0 and infinity. So now here this 2 minus 2 goes to the numerator part, so it becomes minus 2 e power 1 by 4 tau e power minus infinity, and this becomes e power 0, it's e power 0 minus 0. Okay, so that this becomes 0 minus 1, this becomes 0 minus 1. So what we'll get is this 2 e power minus 1 by 4, because here it is plus, here it is a plus, I made it as minus here, so that I can make this as magnitude of tau, magnitude of tau. So both are same, both are same, both are same. So e power 0 is 1, e power 0 is 1, e power 0 is 1. Okay, so the solution for this is this one, option A, 2 e power minus 1 by 4 magnitude tau. Fifth one, consider the AM signal A into bracket 1 plus k sin 2 pi fmt cos 2 pi fct with the power efficiency 1 by 33, and the total power is 297 by 64. The expression for the AM is, so we have to find out the AM expression for the given values of total power and the efficiency. We will see the solution now. So they have given efficiency eta equal to 1 by 33, that is equal to 0.0303. Total power they have given 297 by 64. These are the given. So we know that from the discussion of the video lectures, total power is actually equal to carrier power plus 2 sideband power. Then this can be written for sinusoidal modulation, for single tone modulation, is AC square by 2 plus mu square AC square by 2. We know what is mu. Mu is the modulation index. This is equation 1. Now we know that eta, in the previous problem we solved this one, eta, the power efficiency is equal to mu square divided by 2 plus mu square, equation 2. So from equation 2, what I will try to find is mu. So now what I am trying to do, eta 2 plus mu square, so the cross multiplication, this is equal to mu, and this can be written as 2 eta plus 2 eta plus mu square eta. So 2 eta plus mu square eta, that is equal to mu square, equation 4. And now then this 2 eta equal to minus mu square n plus mu square. So you take this mu square eta to the right hand side, this becomes minus. So or what we can do is, you take mu square is common in this, so take mu square common, it becomes 1 minus eta, and that is equal to 2 eta. So therefore mu square is equal to 2 eta divided by 1 minus eta. This is equation 1. So now we are going to substitute eta value. Eta is already here, eta is here, so it is 0.0303. So that we are going to substitute here, 2 into 0.0303, 1 minus 0.0303. So you will get mu square, actually mu square equal to, you will get 0.0625, and take the square root of this one, you will get 0.25. So mu is equal to, this 0.25 is equal to 1 by 4, which is equal to 1 by 4. So mu square is equal to 0.0625. Remember this one, mu square is 0.0625. Now coming back to equation 1, so this is equation 1, AC square by 2 plus mu square AC square by 4. I am going to substitute mu square value now, mu square. So mu square is 0.0625, that I am substituting here. So therefore total power is equal to AC square by 2 plus mu square I have substituted here. So this is equation 8. So now what I'll do, take LCM of this one. So this becomes 2 AC square plus 0.0625 AC square by 4. Now this is equation 9. Now what I'll do here, this 4, now this equation can be written as 4 times PT. So this becomes cross multiplication. So 4 PT, this side becomes 4 PT, and this is nothing but AC square is taken common. AC square is taken common. So what we will get is 2 plus 0.625. Remember, this is a mu square value. 2 plus mu square. This is 2 plus mu square. So this is nothing but 0.0625, which is equal to 4 times PT. So now therefore AC square is equal to 4 times PT divided by this 2.0625. So if we substitute for PT, which is 297, this is 297, you will get 18.652. So this is text. Okay. So okay. Now this is 97. Please see here. I made a mistake in taking 297. This is 297. So I wrongly written as 67. It is 297. So you will get this value as 18.5625, and then if you divide this, you will get 9. So square root of 9 is 3. So AC equal to 3. I mean A. It is not AC square. A, amplitude A. As per the equation, it is A. So therefore, the expression for the AM signal is, they given AC is equal to A equal to 3, which is nothing but 3 here. So 1 plus 1 by 4 sin 2 pi m t cos 2 pi fc t. This is option C. Option C. This is option C. So mu value is 1 by 4 and A value is 3. A value is 3 and K value. K is nothing but mu value, that is equal to 1 by 4. Okay. And then coming to the sixth one, consider the envelope detector with the load resistance RL and the capacitance C employed to detect an AM signal with the carrier frequency of C and message frequency FM. It is desirable that, now again we can see the sixth one, the same formula is there. Now RLC must be much greater than 1 by FC, much greater than 1 by FC. It is option B. It is option B. So therefore option B, RLC must be much greater than 1 by FC. Seventh one, consider the AM signal again A 1 plus K sin 2 pi m t cos 2 pi fct with the power efficiency of 1 by 9 and a total power equal to 9. So the same method we will follow to find the value of A and the value of K. So see seventh one. So given eta is 1 by 9, total power is equal to 1. So from the problem 5 solution, we know that mu square is equal to 2 eta divided by 1 minus eta. So if you substitute for eta value 1 by 9, you will get this as 2 by 9 multiplied by 9 by 8. You will get mu square. You will get mu square is equal to 1 by 4. Square root of this mu square is equal to 1 by 2. So mu is equal to 1 by 2. Okay. Mu is equal to 1 by 2. Then from equation 10, so in the previous problem number 5, so we know that AC square, which is nothing but A here, 2 plus mu square. 2 plus this is mu square value is 1 by 4. This is 4 times PT, but PT value is equal to 1. So therefore, see here AC square. So therefore, this now if you solve this one, it becomes 8 plus 1 by 4, that is, you will get this is equal to 4, and therefore you will get here 9 by 4. So AC square is equal to 4 divided by 9 by 4. This is equal to, this 4 goes to the numerator, therefore it becomes 16 by 9. So therefore AC is equal to square root of 16 by 9 is 4 by 3. The answer is option B. So A equal to 4 by 3 and mu equal to 1 by 2. Option B. So A is equal to 4 by 3 and mu equal to 1 by 2. Option B. Eighth one, consider the Gaussian pulse e power minus 1 by t square. Let its Fourier transform be denoted by g of f. Demonstrate that differentiation of g of f is minus alpha f g of f. So what is the value of constant alpha? So we will see this one, eighth one. So differentiation of the formula for the Fourier transform g of f with respect to f, we have, so we have minus j 2 pi t gt Fourier transform, Fourier transform pair. This is the differentiation of g of f with respect to f is equation 1. And we also know that differentiation of this gt, so is nothing but again Fourier transform pair j 2 pi f g of f equation 2. So this is by differentiation property of Fourier transform. So equation from equations 1 and 2 we deduce that if the derivative of this, if the derivative of this time derivative g of t is 2 pi t g of t, then it can be shown that the derivative of g of f is minus 2 pi f g of f. So let us for this particular problem, they have given x of t equal to e power minus 1 by t square. So what I will do, I will simply multiply here 2 by pi. So it's nothing but the same thing, and try to differentiate. I will get this as minus 2 pi t g of t. That means from this I can get the differentiation of g of f is equal to, so this 2 pi becomes 4 pi square f g of f. So from they have given this from the problem, differentiation of g of f is minus alpha f g of f. So comparing equation 3 with this equation, we will get alpha equal to 4 pi square. Alpha equal to 4 pi square. So option A. Ninth one, consider the message signal m of t sine 100 pi t. Let the carrier frequency be fc, that is equal to 50 kilohertz, and the carrier amplitude is 20, and with the percentage modulation is 25. What is the approximate power efficiency of the EM signal? Again, it's a very simple substitution problem. So we know power efficiency eta is equal to mu square divided by 2 plus mu square into 100%. So you have to convert this mu they have given 25%, convert this into a number, not percentage into a number, it becomes 0.25. Substitute in this formula, you will get this as 3.03. Option C, 3.03. Last one. So this is again consider an ordinary amplitude modulated signal with the modulation index mu and sinusoidal message signal. The power efficiency of this signal, it's well known. We know that the power efficiency eta is mu square divided by 2 plus mu square. Option C. Option C, mu square divided by 2 plus mu square. Thank you, viewers. Kindly go through the solutions. It will help you for the end semester exam, at the end of the exam.